Hi, in this video we look at how we can convert between degrees and radians, and we'll also be looking at coterminal angles and reference angles. As we have discussed previously, to determine an angle in radians we divide the length of this arc by the radius, and that gives us this angle. So obviously the angle will increase because the length of the arc will increase. In other words, this value here will increase. So what happens when the length of the arc is equal to one complete circumference? So this whole thing should remain red, but it doesn't. So just imagine, right? I'm talking about it's one complete revolution. So notice when this reaches here, the length of this arc will be the circumference, and so that's going to be 2 pi r. And when I divide 2 pi r by the radius, I get 2 pi. So, and this I imagine you knew already, 2 pi is the equivalent in radians to 360 degrees. Obviously, if we only had half a revolution, then it would be pi r, half the circumference, divided by r, which would then give us pi. So 180 degrees would correspond with pi. And of course, a quarter of a revolution would be a half. Pi r divided by r would then be simply pi over 2. Let's go over this once more. The angle is defined as the ratio of the arc to the radius. For an angle of 360 degrees, we know that the arc is going to be equal to the circumference. That's 2 pi r, so it's going to be 2 pi r divided by r, 2 pi radians. So 360 degrees is equal to 2 pi radians. Of course, if we make the arc equal to half the circumference, then it's a half of 2 pi r, which is just pi r. And then of course we divide the length of the arc by the radius, giving us pi. So 180 degrees corresponds to pi. And if we do a quarter of the circumference, that means we'd be dividing this by 2. This is half the circumference divided by 2, and now we get a quarter of the circumference. So note, this is a quarter of the circumference, right? It's dividing 2 pi r by 4. So this is the length of the arc, that's the radius, that leaves us with pi over 2. So 90 degrees corresponds with pi over 2 radians. So what is significant here is the fact that the ratio of the angle in degrees to the angle in radians is a constant. Notice that 360 corresponds with 2 pi, 180 corresponds with pi, and 90 corresponds with pi over 2. All of these are equal. 360 over 2 pi is the same as 180 over pi, is the same as 90 divided by pi over 2. So this leads us to this relationship, that the angle expressed in degrees divided by the angle expressed in radians is a constant and equal to 180 over pi. Now this is not the only expression we could use. We could say 360 over 2 pi. We could also say 90 over pi over 2. But I think this is the most convenient and simplest to write. So if let's look back here, we could say the angle in degrees over the angle in radians is equal to this, or this, or this, because they're all the same. So of these three, which do you think is nicer to work with? I would say this one. So that's what we have here. So let's carry out some conversions now. So first we are asked to convert 87 degrees to radians, and so we can simply use this relationship here. 87 degrees over the angle in radians is equal to 180 over pi. We make this the subject of the expression, and we find that the angle in radians is 0.48 pi radians. It helps sometimes to see some intuition here. If you're given the angle in degrees, all you need to ask is, well, what fraction of 180 is that angle? And then multiply it by pi. In other words, 87 degrees is 0.48, almost a half of 180. Remember, 90 degrees is a half of 180. 87 degrees is 0.48 of 180. In other words, this fraction is 0.48, so it's 0.48 of pi. So when converting to radians, given degrees, you just need to find out what fraction of 180 degrees is that angle that you are given. So 87 degrees, what fraction is it of 180? Multiply it by pi. And so you can then skip the step because this intuition here is pretty clear. Now we're given 4.5 radians and asked to convert it to degrees. We use this relationship again, and we make the angle in degrees the subject, and we get that it's 4.5 over pi times 180. And so we get 257.8 degrees. Again, it would be helpful if you could see the intuition here, which would allow you then to skip this step. You're given an angle in radians. All you need to know is, well, what fraction of pi is it? And since pi corresponds with 180, once you get that fraction, you multiply it by 180. So 4.5 divided by pi, that gives us 1.432. So we just get this ratio here and multiply it by 180, which then gives us 257.8. Here we have to convert to radians again. So notice we can go directly here. We can say, well, 675, what's the ratio of 675 to 180? And whatever we get for that ratio, we multiply it by pi. So we're either multiplying by pi or by 180, depending on what we're trying to find. So this gives us 3.75 pi. And here, we're going to multiply by 180 degrees because we want to convert this to degrees, and we need to find the ratio then of 25 to pi. And so 25, the ratio of 25 to pi, it's not there in the... That's going to be 7.96 more or less. So this then is going to be 7.96 times 180, which gives us 1432.4 degrees. So that's why at the beginning of this video we saw these two equations here. These should be pretty familiar to you now. Some students prefer to just remember this one equation, which you don't need to really memorize it by rote. It should make sense. But sometimes these are easier, so if you don't mind memorizing these two, these should be easier to work with. So the angle in radians, well, you just find out the ratio of the angle in degrees to 180 and multiply it by pi. If you want the angle in degrees, you find the ratio of the angle in radians to pi and multiply it by 180. And so that's that. You should now be able to convert easily between radians and degrees. Now let's look at coterminal angles. So coterminal angles are angles that have the same terminal side. Simple as that. So for example, this angle is 140 degrees. Well, we could also go this way and say that it's minus 220. So 140 and minus 220 are coterminal. They have the same terminal side. Now for every angle, there is an infinite number of coterminal angles, because all we need to do is go adding or subtracting 360. So for example, let's look at 0 degrees. 0 degrees is the same as what? 0, 360, 720, 1080, 1440. If you had 100 degrees, it's going to be, you add 360 to it, you get 460. You subtract 360, you get minus 260. So these are all coterminal angles. So this angle here, for example, if I keep adding 360, I get 500, then 860, then 1220, and so on. Likewise, I could subtract 360. So 140 minus 360 is minus 220. If I subtract 360 again, it becomes minus 580, and so on. So I think you get the picture. So for each of these, let's find 3 coterminal angles. Well, for 65 degrees, let's work with positive angles. That's going to be 65 plus 360, 425, 785. So I'm just adding 360 to this angle over and over and over. I could also subtract 360, so that would be 65 minus 360 minus 295 minus 360 again minus 655. And so we can do that for all of these. 154, it's going to be 154 plus 360, 514 plus 360 again, 874. Or I could go the other way, 154 minus 360 minus 206 minus 360 minus 566. So for any given angle, the coterminal angle is found by simply carrying out one complete revolution either in the positive direction or in the negative direction. So I can add 360 and then add 360 and then add 360, or subtract 360, subtract 360, subtract 360. Finally, we look at reference angles. So every angle has a reference angle, and it's the smallest angle formed between the terminal side and the x-axis. So here, if an angle is in the first quadrant, the reference angle is the angle itself. If the angle is in the second quadrant, notice this is the angle here. Well, this is a reference angle. It'll always be positive, and so this angle here is shown as the angle between this red arrow and the x-axis. So for example, if this is 120, this is 60 degrees, then that's 60 degrees. In other words, reference angle then for 120 degrees is 60 degrees. If it's in the third quadrant, notice the reference angle is going to be this angle here. And so if we show it in the first quadrant, it's going to be this one here. So let's say this is 190 degrees. Then the reference angle in here is going to be 10. Obviously this is more than 10 degrees. Not just by way of example, let's suppose it's 200 degrees. If this angle were 200 degrees, then this would be 20 degrees, and that would be 20. And if it's in the fourth quadrant, let's say it's 300 degrees, well then this would leave us with 60 degrees, and of course then this would be 60 degrees. So the reference angle is, once more, the smallest angle formed between the terminal side and the x-axis. So for 125 degrees, you simply get a sense of where 125 degrees is. It's in here, and that would leave us how much here then? The reference angle would be 180 minus 125. That's 55 degrees. In the case of 230 degrees, 230 places us somewhere in here, and then we just simply say 230 minus 180. So you don't need to memorize those formulas, they should make sense. If you want this angle in here, you have to say 230 minus, because 230 comes all the way here, 230 minus 180, that's 50 degrees. So the reference angle here is 50 degrees. For 295, that places us over here somewhere. And then to get what the reference angle is, we simply say what? 360 minus 295. And this is going to be 65 degrees. So the reference angle here is 65 degrees. 560 degrees, well, we need to subtract multiples of 360 to know where this is. So if I say 560 minus 360, that's the same as an angle of 200 degrees. In other words, both 560 and 200 are coterminal. So 200 degrees places us around here. So 560 is one revolution of 360 plus 200 more. Of course, then the reference angle is going to be 20 degrees. That's 200 minus 180. This angle is 20 degrees. So the reference angle for 560 is 20 degrees. Okay, so that's it for this video.